We are talking about isosceles triangles and equilateral triangles. It's a little lengthy. My intention was to split this up into 2 lessons, but because I have to be gone tomorrow for my mom's funeral, I have to do it all today. Okay? So it's really just a little bit extra. So welcome to that. Isosceles triangle is a triangle that has at least 2 sides congruent. So any triangle where you have at least 2 sides congruent is considered isosceles. The 2 sides that are congruent are called legs. Okay? The other side is called a base. The 2 legs, 2 sides are called legs. The angle in between the 2 legs is called the vertex angle. And then the angles on either side of the base is called a base angle. Okay, so those are the parts of an isosceles triangle. And we have 2 theorems that we want to talk about. And they're called the isosceles triangle theorem and the converse of the isosceles triangle theorem. Okay, they kind of work back and forth with each other. And the isosceles triangle theorem says that if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So you see in this triangle here how AD and BC are congruent? This tells us that the angles opposite, which are the base angles, that they are congruent. Okay? So if the 2 sides are congruent, then the base angles are congruent. Okay? Now, the converse of that is also true. Okay? It says in the converse, if 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So it works backwards also. If these 2 base angles are congruent, then that tells me that the sides opposite are going to be congruent to each other. So directly across from each other, right? So you can also think of it as if the base angles are congruent, then the legs are congruent. Okay? And up here, if the legs are congruent, then the base angles are congruent. Okay? So go back. So let's do a couple of examples. What is the value of x? Okay, so we look at our problem, and we can see that I have 2 sides of the triangle that are congruent. What can we conclude from that? That the base angles equal the same, right? It's not these 2. It has to be the base angles. Okay? So this is 28, which means this is 28. So then what should I do to solve for x? What do I know about all the angles of a triangle? No, on the same side. They equal 180 together. Okay? So I would add 28 plus 28 plus 5x plus 9 equals 180. They all add together to equal 180. And so this is 56, 65 plus 5x equals 180. What? There might. Yeah, because the two legs were congruent, those base angles have to be the same. So since one of the base angles is 28, the other one has to be 28. Alright, so you subtract 65 from both sides, and that gives me 115. And then you divide both sides by 5, and x is 24. Alright, look at the next problem. What kind of triangle is this? What do you see? What they tell me? It's isosceles, right? So the 2 legs are congruent. What can we conclude from that? That the base angles equal the same. So these 2 angles down here are equal, right? Okay? So I'm going to figure out x, I'm going to set them equal to each other. We know they're congruent. So we get negative 4x plus 9 equals 8x minus 3. And we're going to solve for x. So we're going to add 4x to both sides. And that gives me 9 equals 12x minus 3. And then I'm going to add 3 to both sides. And so x is equal to 1. So if the legs are congruent, then the base angles are congruent. Okay? That's the isosceles triangle. Now let's work the other way. Let's look at the converse of the isosceles triangle here. And we want the length of all three sides of the triangle. So we need to figure out what x is. Okay, what do we know here? All the sides equal something different. The angles equal 180, not the sides. The sides is the perimeter. They tell me that P and Q, angle P and angle Q, are equal to each other. It tells me that P and Q are equal to each other. How does that help me? What else does that tell me? That those two sides opposite are equal, right? Okay? Alright, so since these base angles here are congruent, the sides opposite are congruent. So, to find x, I'm going to set x plus 20 equal to 8x minus 3. And 8x over 3. 8x divided by 3. Alright. Okay. So what am I going to do to solve this equation? Multiply by 3, right? I want to get rid of the fraction. We don't like fractions, right? So if I multiply this side by 3, my 3's cancel. So whatever I do to one side, I have to do the other. Okay? So I have to distribute, it gives me 3x plus 60 equals 8x, because the 3's cancel. Okay? It's like 3 over 3 is 1. So then I got to solve for x. I'm going to subtract 3x from both sides. And I end up with 60 equals 5x. Divide both sides by 5. Okay, now I need the length of PR, QR, and PQ. What do we know about PR and QR? No, they don't equal 12, but they equal each other, right? Okay, so we know that PR and PQ are equal, but you've got to plug 12 in, okay, to get a length. So if I plug 12 in, what's the next side? 32, which means this side is also, there's also 32. Okay, so PR and RQ, PR and RQ are both 32. And then we need to find PQ. Okay? So we still have to plug 12 in there. 12 times 6 is 72. Minus 12 is 60. So PQ. Alright, any questions on what I did there? I had to get the fact that these two sides were equal. I set them equal to each other to figure out x. Then I had to go back and plug x in for each side. And I knew that PR and RQ were equal, so they were going to be the same. I didn't even have to mess with that fraction. I could have. It wouldn't have been that hard. Alright, here's another one. Use the figure below. What is the value of x? What are the length of all three sides? So a similar question. Okay? You see these two angles here are equal. What does that tell me? That the two sides are equal, right? Okay. So to find x, I'm going to set those two sides equal to each other. And I'm going to solve for x. So subtract 4x from both sides. 4x minus 1 equals 5. And then add 1 to both sides. So I get 4x equals 6. Divide both sides by 4, and x is 6/4, which reduces to 3/2, right? You could also use 1.5 like your calculator. I'm going to work with 3/2 just because the numbers are even, it's easy to work with. Okay? Does everybody understand how I got x? Now we got to go back and plug in, and we know that these two sides are the same, right? So I could put 3 halves in for either one. Okay? Let's put it in for this one right here. If I do 8 times 3 halves minus 1. Now there's some people like, oh, fractions. Well, what happens here with this 2? Will it divide evenly into 8 when you cross cancel? So this becomes a 1 and this becomes a 4. Okay, because 2 goes into 8 4 times. So 4 times 3 is 12 minus 1, which is 11. So each one of these sides is 11. Okay, so the sides are 11 to 11. And then I got to come over here and put 3 halves in here. 2 times 3 halves plus 11. What happens here? Huh? 2 goes one time, right? So they cancel each other out, and I'm left with 3 plus 11, which is 14. So my sides are 11, 11, and 14. Alright, so any questions about the isosceles triangle and its converse? Here we go. If the legs are congruent, the base angles are congruent. If the base angles are congruent, the legs are congruent. Okay. Alright. Now, this is kind of a little extra tidbit about isosceles triangles. Okay? It says, if a line or a line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. What that means is, okay, here, big picture, you have an isosceles triangle, right? Right here, this is my isosceles triangle. Because it has these 2 legs that are congruent, right? Okay, if this vertex angle, what connects the 2 legs, if it is bisected, that means it cuts it into 2 equal parts. If it's bisected, then it says that this segment goes down to the opposite side and it's perpendicular to it, and it bisects. Okay? So if you have an isosceles triangle, and you have a segment that bisects the vertex angle, then that same segment goes to the opposite side, and it's perpendicular to it, which means it forms a right angle, and it bisects the opposite side, so it breaks it into 2 equal parts. Okay? Right? Okay, so let's apply that. Okay, here's the figure shown. What is the measure of angle RSQ? So RSQ is what we're looking for right here. Okay? Alright, now look at the big picture. What kind of triangle is it? It's isosceles, right? It's turned upside down, but it's isosceles. What do we know if it's isosceles? The what? SR is equal to PS, right? Which means what about the angles? They're equal, right? So if this is 31, then this is 31, right? Now, you see how this QS bisects angle S? See that? If it bisects angle S, and it goes to the opposite side, what does it do? Okay, what? Makes these 2 sides congruent, right? So if this is 4, this is 4, right? And what does it do? What kind of angle does it create? A right angle. Okay? So since this QS bisects the vertex angle, it goes on to the opposite side, and it makes a right angle, and it bisects. Okay? So to answer the question, it says, what is the measure of RSQ? Okay, RSQ is where I have a little x. Okay? We know we have a 90-degree angle here and a 31-degree angle there, right? What do we know about all the angles of a triangle? 180. So, I can take 180, add these 2 together, which would be what, 121? And subtract it from 180. So that gives me, what, 59? So this little angle right here is 59 degrees. Okay. What's PR? What's the PR? No? No, the length of PR, the second PR, not the angle, the second PR. From here to here, from P to R, what's it going to be? It's going to be 8, right? Because this QS bisects it. We knew that QR was 4, so we could let PQ be 4. So PR is 4 plus 4, which is 8, right? Okay, 8. prefabricated house is delivered to a foundation in two symmetric tabs. A prefabricated house is like a double wide trailer, okay? It's cut in half, okay? So they have to deliver it into two parts being put together, okay? Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route from the underground house? So what we have to do is we have to figure out how tall this house is and decide whether the trucker can go that path or if he needs to find another way to get there. Okay? Alright. Now, here's my house. From here to here is 10. Okay, so this length right here is 10. I need to figure out what that length is so I know the whole height. Okay? Now, if we look at this top triangle, what kind of triangle is that? It's isosceles, right? Okay? And you see how they broke this? And so these two angles there are equal. And when they break that, break it in half, it bisects that angle. What does it do to the opposite side? It breaks it too, right? And since all the way across is 28, each one of these pieces are going to be 14. With me? Okay. I still don't know how tall it is. But what do I have going on right here now? I have what kind of triangle? I have a right triangle, right? Only thing I don't know is what that little height is, yes? What can I do to figure that out? It has a 90-degree angle. It's a right triangle. Look what we get over here.
So you do A squared.
You're going to do A squared plus B squared equals C squared. What's this? The A and B or the C? The A, one of the legs, right? Okay. The C is across from the right angle. So we're going to do H squared plus 14 squared equals 16 squared. Okay, so we have H squared plus 196 equals 256. Subtract 196 from both sides, and I get H squared equals 60. Okay, and so what did we say we had to do to get H? Take the square root. So if I plug that into my calculator, I get square root of 60. I'm going to get my height is about 7.7. Okay? So this right here is 10. This is 7.7. What's the total height? Huh? Almost 18, isn't it? 17.7, right? Feet. Is the trucker going to have to find a different route? Absolutely, because if the building itself is 17.7, it doesn't have to be up on a trailer, so it's going to be even higher, isn't it? Okay. What might happen if I didn't do that? Buy by roof or buy by bridge, right? Okay. When you guys were little, they had an accident in Weber's Falls. You ever heard of Weber's Falls? I think it's like on the way to Sallisaw. I'm not really sure where it is. Anyway, there's a bridge that goes over a river. Okay? And there's barges, like the Catoosa, that go through there carrying stuff, right? Well, this boat captain had not gotten enough sleep, went under the bridge, and what he was carrying was too tall. So he goes through, hits the bridge. The bridge falls to the ground. Part of it, like a big section of it, falls to the ground. On top is a highway. People driving 65 miles an hour. Guess what happened? Bam, 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 right on top of each other. It's like 12 to 15 feet. Because the guy didn't make sure that his load was below the height. So, should have done a little math, right? Too tired, but you still should have done a little math, right? So a lot of things take into play. Okay, so there is math in everything. Okay?
Well, I'm afraid there wasn't much life afterwards.
Or should they put what's the
No, he should have known. No, you drive. Have you ever noticed when you go under a bridge, it has a height clearance? Yeah, it's like whatever, 14 feet, 6 inches or whatever. Okay. So being a trucker or being a boat captain, that's something that you should be cognizant of. you should know, I need to know that whatever I'm taking under this bridge to the edge, because it could cost you or somebody else your life. Not just your car. You should also be, thinking about that.
That's
Two,
why it says
more than likely what you carry in your car is not going to be too high, but still,
That's why it says take a different one.
that's why I should take you.
Exactly.
Okay, last thing, and I know you're getting tired of listening to me, so last thing, equilateral triangles, okay? Equi means equal. Lateral means side, okay? So an equilateral triangle means equal sides, right? All three sides are the same. Now, we have a couple little theorems here, or concepts you need to make sure you understand. An equilateral triangle is always equiangular. What do you think equiangular means? Equiangular. Equi means equal. What does angular mean? It's angles, right? So if a triangle has equal sides, it also has equal angles. The converse of that is true. If you have an equiangular triangle, it's also going to be equilateral. All right? So basically, if all the sides are equal, all the angles are equal. If all the angles are equal, all the sides are equal. Now, if this is true, what is the measure of each side? An angle. Not side, you don't know side, but what's the measure of each angle? No. 9 times 3 is 270 degrees. How many degrees are in a triangle? The angles of the triangle. 180. So how would you figure out what each angle measures? Divide it by 3. So 180 divided by 3 is 60. So in an equilateral triangle, it is equiangular, and all the angles are 60. Always. Okay. Alright. So, a couple questions here. Find the angle measure in the isosceles in an equilateral triangle. Now let me ask you, is an equilateral triangle considered an isosceles triangle also?
Yes.
Yes. Because an equilateral triangle, an isosceles triangle has at least 2 congruent sides. Does an equilateral triangle have at least 2 congruent sides? Sure. Okay. Now, are all isosceles triangles equilateral? No. Okay. No. Alright, so what we learned about the bisecting the angle of the perpendicular bisector is going to hold true also in your equilaterals. Alright, so we want to find the measure of angle CBD, or if the measure of angle CBD is 130. What is the measure of BAD? BAD, which is this little angle right there. That's what we want to know, okay? Now, what kind of triangle is this? Equilateral, which means it's also equiangular. And if it's equiangular, what are each one of these angles? 60. So this little angle right here is 60. This whole big angle is 130. So what does it make the adjacent angle? Right? Okay. So now we're working with this guy right here. What kind of triangle is it? This is an isosceles triangle, right? And what do we know about isosceles triangles? Sides are congruent so that the base angles are congruent, right? Okay, so if this vertex angle is 70, I need to find out what these two are, right? So I'm going to take 180 minus the vertex angle. That gives me 110. Now that's 110 for both of those, because remember they're the same. So what would I do to find the one I'm looking for? Divide by 2. Okay, because they're the same. There's 2 of them and they're the same. So each one of them is 55 degrees. Okay? Questions on that? Okay, let's do another one. That was last 2. We're almost done. Alright. What is the measure of angle U? That's what we're looking for right there. Okay? Now, this is what I'm given. So I got to start here and work my way over to the other side. David, you listen to me? Okay, good. Alright. So what kind of triangle is this guy? That was equilateral? That was isosceles, right? Okay. And we know that the vertex angle is 72. So I need to find these two, right? What do we know about these two? They're equal, right? Okay, so just like we did in the one above, I'm going to do 180, and this time minus 72. That's 108. Okay, and both of these are the same. So what do I do to the 108? Divided by 2, which is 54. So this is 54, and this is 54. Okay? I still got to get over here. What do I have going on with both of these triangles? This is another isosceles, right? All I know is what this is. Can I figure out what this one is? Can I figure out what that angle is? What's the relationship there? Two angles that make a straight line. What's that called? I know, we're getting way back there and cleaning out lots of cobwebs, right? Two angles, they're linear pair, right? And a line measures 180. So if this one's 54, to get the other one, I have to subtract from 180. So I do 180 minus 54, which is 126. So now this little angle right here is 126, right? Okay, I'm almost there. What do I know about these two? They're equal, right? All three of these add up to 180. So if I go back and do 180 minus 126, that gives me 54 for both of those together. So what should I do? Divide by 2. And that gives me 27. Okay? So the measure of angle U is 27 degrees. Yes? You can do that, okay? She said she took this 54 and divided by 2 in the first place. What happens there is you remember, and I didn't want to throw too much at you, but see this right here is, this 54 is an exterior angle of this triangle, and remember your exterior angle is equal to the sum of the remote interior angles. So you could do that, okay? I just didn't want to throw too much at you. That's good, glad you noticed that. So this is an exterior angle, you can divide by 2, and that gave you that, okay? Alright. Last one. This one's similar. Okay, find the measure of each angle in the figure. Now they don't give us any measures right off the bat. Okay. But what do I notice about this triangle right here? It's equilateral, right? And if it's equilateral, what does each one of the angles measure? Parker? You listening to me? Okay, good. David wants to sleep on it.
Mama, I go wild.
Okay, so each one of these angles are 60. Now I'm trying to find P and O, which is this one right here. What's that going to be? 120, because we've got a linear pair right there, yes? Okay, if I highlighted this triangle here, you see how the green and the blue together make a straight line? So this is going to be 120. 180 minus 60 is 120. Okay? Alright. Now I want NOP, which is this one right here. Which is 60 divided by 2, which is going to make each one of them 30. Okay. First of all, you know these two are equal because this green triangle is isosceles. You see that? Okay. And so these two are equal. Now, if I wanted two things, I could use the exterior angle, which is 60, divided by 2, to get the remote interior angles. Okay? Or, I could have remembered that all the angles of a triangle equal 180. So I do 180 minus 120, and what's left needs to be divided by 2. Does that make sense? Okay. Alright, any questions? If it's isosceles, the legs are congruent. And you know that if the legs are congruent, then the base angles are congruent, right? And converse to that, if the base angles are congruent, then the legs are congruent. Yes? All the sides of an equilateral triangle are equal. All the angles are equal. They all measure 60. And the last thing we learned is that if you have an isosceles triangle and you draw a segment that bisects the vertex angle, then it's perpendicular to the opposite side, and it also bisects the opposite side. Okay? Whew, that's a lot, yeah? Okay? Alright.